Yesterday, I went to a beach with my friends, but I didn't notice that I was carrying a bar magnet in my pocket. While making sand castles, the magnet slipped out of my pocket and fell into the sand. We observed a very interesting thing. We noticed that the magnet had attracted some particles towards its ends. Only towards its ends. Now, does this happen with all magnets? Let's find out. We know magnets attract iron. Say, we take this bar magnet and dip it into metal pins. What do we notice? Yes, all the metal pins are sticking mostly to the ends of the magnet. But why only to the ends? Why not in between? Because a magnet's attracting power is maximum at its ends. And so, we give special names to these ends. We call them poles. All the magnets we see have two poles, where they have maximum attracting power. This is true for any magnet we take. One more interesting thing about poles is that even though both these poles seem to behave similarly, each pole has a character of its own. Let's do an activity to find them out. So, this is a bar magnet. Let's mark its ends A and B. And here is a string. We'll tie the string at the center of the magnet such that the magnet can freely rotate around it. Now, if we release the magnet, we can notice after some time that the magnet settles itself to a particular direction. Okay, so it's quite settled, right? Now, even if we displace it again, it will come back to the same position. Let's find out what direction it's pointing. Observe, the magnet is aligned to the NS direction. Also observe, this A end of the magnet is always pointing towards the north. How much we displace it, it's again coming back to the same alignment. And the end A always points towards the north, and the other end towards south. It's not the other way. So aren't the ends different? The end or the pole which is pointing towards north is called the north-seeking pole or just the north pole. The other, B, pointing towards south is called the south-seeking pole or the south pole. So in magnets, we also have the north poles and the south poles. Isn't it interesting? This aligning property of a bar magnet along the NS direction is actually quite useful. Very useful in situations where people travel through oceans, deserts or jungles where the sense of direction is completely off. That's when, just by using a simple magnet and a string, NS direction can be easily figured out. So a magnet can also show direction. It has a directive property. Ancient people were also smart and were aware about this property of magnets. Let me tell you an interesting story. The Emperor of China, Wang Ti, had a chariot with a statue of a lady with her arm extending out. The statue's arm always pointed towards the south. The emperor would use this statue to navigate his long travels all around Asia. Wang Ti had a statue of the lady, and we have this specialized magnetic device called the compass, which helps us to find direction. A compass has a magnetic needle which always points towards the North Pole and the South Pole of the Earth. We know so many things about a magnet now, about its poles, about its directive property. Why don't you try to find north in your home with a magnet? And remember, we stay curious.